Complex numbers, example 17. This is one of those classic questions that comes up quite a lot, and it's a sort of standard method, so you need to make sure that you have a few goes at practicing this. The algebra is just C1 algebra, so you should be fine with that. So it says, find the square roots of 16 minus 30i. Now, the square root of a number means that, let's say, if x plus iy was the square root of this number, that means that if I squared this square root, I would get the number itself. So if this was just 16, this would be 4. The square of 4 is 16. So something squared gives us this number. So I'm going to go ahead and multiply this out, and we'll see if we can work out what x and y could be. So multiplying that out, write it out as 2 brackets if you can't do it all just in your head. And so we'll get that x squared, I'll do the middle bits in one go, so that's 2 lots of xy times I. And then the last term will be y squared, I squared. Now I squared is minus 1, so that's just going to be minus y squared. So check you're okay with that part. And what you'll see again is we've got real and imaginary parts on the two sides of the equation. So x squared and minus y squared are real, they don't have any i's in them. So x squared minus y squared must be equal to 16. And then if we look at the imaginary parts here, take off the i's, you're just looking at the coefficients. So minus 2xy, sorry, that should be plus 2xy, another error, plus 2xy is equal to minus 30. Now, these are simultaneous equations. You've probably solved similar to this in C1. What I'm going to do is rearrange the second one and sub it into the first one. So if I rearrange this, you can either get x equals or y equals, doesn't matter, whichever you prefer. So I'll rearrange it and I'll put y equals minus 30 divided by 2x. And I'll cancel that down. 30 over 2 is 15, so it's minus 15 over x. So that's the expression I'm going to put into this quadratic. So x squared minus y squared equals 16. Okay, so let's see what we've got now. So we're going to have x squared, and then if we multiply it out, 15 squared is 225, and the denominator will be x squared. Notice how when you square it, this minus goes, but we've still got the one in front, is equal to 16. Now, you may not be too familiar with equations like this, but we always want to get rid of stuff on the denominator, so I'm going to multiply through every term by x squared. So the first term will become x to the 4. Middle term is just now 225, and on the right hand side, don't forget that needs to be multiplied by x squared as well. So I'll bring this over to the left hand side, and maybe you've seen something like this before, maybe you haven't. You perhaps won't have done much factorising of quartics. It is a quartic, but it looks a bit like a quadratic, doesn't it? The powers are different, but the structure's the same, and you can actually factorise it like you would do a quadratic. At the beginning, x to the 4 can be split into x squared times x squared, and then 225, well, there's various different ways of splitting 225 into two factors, but I think given that we've got a 16 here, I think 25 and 9 might be a good choice. So looking at the signs, I think it's minus 25 and plus 9. So we've got two possible solutions: x squared equals minus 9, or x squared equals 25. Now if you think about what x is the real part of this complex number. So if x is the real part, it can't be complex. That doesn't make sense. If I took the square root here, I'll be doing the square root of minus 9, which will be 3i. But the real part can't be 3i. That doesn't make sense because 3i is complex. So that one is not the one we want. This is the one we want. X squared is 25. And so x is plus or minus 5. Now, if x is 5, you can sub back easily into this expression here. Minus 15 divided by 5 is minus 3. So we know that one of the square roots is 5 minus 3i, x plus iy, and y is negative. Alternatively, if x is minus 5, sub it in here, y would be 3. And so the other square root would be minus 5 plus 3i. And you'll see that, like with ordinary, if you like, real numbers, they are the negative of each other. And that always works out to be the case.